Howdy folks, and welcome to part 7 in my comprehensive guide to pfSense 2.3. This video is entirely about DNS. So in this video, which is broken up into 3 distinct sections, I want to go over a quick review of DNS and how it works and what it does. I want to go over Unbound and what it does in particular. I'm then going to go over how to benchmark and select the best DNS servers for where you live. And I'm going to finish up by going over configuring the DNS resolver in pfSense. So DNS is used to resolve human-readable network resource names to their associated IP addresses. So effectively, DNS is used to translate a domain name, such as google.ca, which is the example I'll be using, into its associated server's IP address, which for me happened to resolve to this IP address, but of course Google has many servers across the globe. So there are many things that can resolve to depending on where you are. So I want to go over a bit of an example with what I'm calling conventional DNS. And when I say that, I mean this is probably how your network right now works. So on the left-hand side, we have a private network. It has a couple client devices on it. We have a router, which is, we'll say it's not a pfSense router. And we have a modem. We have a cloud sort of depicting the internet. And then we have a DNS server, which has an IP address, of course. Now, the modem knows the IP address of the DNS server, and it knows this because your internet service provider, your ISP, has told the modem through some means what that IP address is. So the modem knows the IP address of the DNS server, and the modem will use Dhcp to propagate that IP address to your router. And your router will then use Dhcp to propagate that address to the client devices. So now, let's say that one of the clients wants to know, wants to resolve the address google.ca. It wants to, let's say, load a web page at google.ca. It needs to know what the IP address of that server is. So it's going to use the DNS server address that it knows, the 99 address in this case, and it's going to send a simple DNS request through the network, and it's going to eventually end up at that DNS server. That DNS server is going to do a lookup, and it's going to look in its database, find what the IP address associated with that name is, and then it's going to reply, and of course that's going to get sent all the way back with the answer to that device, and then that device can, of course, now know where, in this case, google.ca is, and then it can execute its connection and do all its associated stuff, which I'm not going to go over because that's not important for this video. Now, the speed at which this name resolution process takes place is normally known as the round trip time, or the RTT. And this is the amount of time it takes for the DNS request to, or the query, to go from your client device through the network to the DNS server, and then the response to come all the way back to your device. So one complete trip. That is the round trip time. Now, a domain name must be resolved before that client device can even begin to connect to that server or that host, because of course, you can't connect to something that you don't know where it is. And as a result of this, the round trip time of every DNS lookup plays a relatively large role in the performance of web resources, in particular web pages. Whenever you load a web page, the domain name in the URL has to be resolved first, of course. Then the browser can connect to that server and download the HTML. At that point, the browser then parses the HTML, and it has to resolve all the other domains for all the other resources in the page. So of course there are going to be images, scripts, style sheets, all that stuff embedded in the page, and they all can be, and often are, hosted on different domains or subdomains, and therefore they have to be looked up independently before your browser can connect to and download those resources to fully assemble the web page. So your browser is going to make several waves of DNS lookups during the loading of a web page. And the faster that those DNS queries, the faster those results get returned, the faster the page will load in general, because it's a sort of a serial process. Their queries have to finish first before the actual downloading of the page content can begin. So to tie this into pfSense, both the DNS resolver, which is the unbound service, and the DNS forwarder, which is the DNS mask service, can be used to act as a DNS cache, which exists between your client devices and the DNS servers on the internet. Now, I'm only going to be talking about unbound in this video. I've mentioned before that DNS mask used to be the old, in fact, the only DNS service in pfSense up until 2.2, when unbound was added and has become the standard, and I can see pfSense moving towards unbound. So even though I personally use DNS mask at home simply because I have an old config, unbound seems to be the new thing, and that's what I'm going to be talking about exclusively in this video and this video series. So I want to replay that last example, but in this case with a pfSense box running unbound. So everything's exactly the same, except in this case we can assume that that router is a pfSense router. So of course the modem is going to know the DNS address, same as before, and it's going to use Dhcp to propagate that to your pfSense box to unbound. Nothing has changed there. However, using a benchmarking technique, which I'm going to go over in the next section of this video, you may have discovered one or more other DNS servers that your modem doesn't know about that are actually really fast. And you can manually enter these into unbound or into pfSense in general, and it can use multiple servers to improve speed, and I'll show how that works in this example. So that's just where that other address came from. It was manually entered. And your pfSense box will propagate via Dhcp its address as the DNS server for the network. So rather than propagating the internet addresses to the clients, it itself is a DNS server, and it propagates that address to the clients directly. So replaying the same example as before, we have a device, client device, it wants to resolve google.ca. So it sends this request to the pfSense router to unbound, which then receives it. Now, of course, unbound has no idea where google.ca actually is. So in this case, it's going to create, in this case, two requests simultaneously to those DNS servers on the internet. So rather than putting all of its eggs in one basket and sending one request to one DNS server, it generates one request for every DNS server you have, and it sends them all out simultaneously, and they will all reach the DNS servers at different times. Because at the end of the day, we don't really care which server services the request, because in theory they should all return the same address or an address that will work in the case of something that has multiple servers running it. So we only care about which one responds first. So in this case, it could be one or the other, and it will fluctuate depending on the DNS server's load, random internet traffic, what path through the internet the data takes, because of course the internet always changes paths, things like that. So I'm just going to ignore and assume that the 88 server on the top returns a result first. So we're going to ignore the 99 server. So of course this DNS server is going to actually know where Google.ca is in this situation, and it's going to reply back to unbound on your pfSense box. So you're going to have seen this in previous parts, and you can kind of see where this is going to go. But unbound is going to use those oodles of memory you have in your probably overpowered pfSense box, and it's going to create a table. It's going to use that RAM for something useful, and it's going to cache the result of that DNS query in RAM. So it's going to basically create a record that says that Google.ca resolves to that IP address. It's also going to include a TTL, or a time to live, which is basically an expiry. And what that means is that once that record has existed for, in this example, 3,600 seconds, which is 1 hour, DNS mask or unbound will basically just destroy it and request new data from an internet DNS server. And this simply keeps the record fresh and up to date. So in the event that the server configuration changes, maybe it moves IP addresses, for example, it will ensure that you always have a relatively recent and working address. And I'm going to talk more about expiry and things like that when I actually get into the unbound configuration. But anyway, it'll make a record of that, and then of course it will forward that packet back onto the client that originally requested it, and then the client, of course, then knows where the server is and can make its request as usual. So you can sort of see where this is going. Let's say that there's another device on your network that wants to access Google.ca, or maybe even another program on the same computer that wants to access Google.ca. In that situation, it's going to have the same query. It's going to make it to the pfSense box, which is its primary DNS server, and it's going to quickly look through the cache and say, oh, I already know where that is. I don't have to do anything else, and it will just return the address right away. No connection to the internet is required. Now, to give you an idea of how much faster this caching is relative to going out to the internet every single time, to get a packet from a client device to your modem and back again, so the full round trip time, on a small network like a home network is sub 1 millisecond. So it's, probably 200 to 300 microseconds. Very, very fast. Larger networks, maybe 1 or 2 milliseconds, but it's generally not that long whatsoever. But on the other hand, to go from the modem out into the internet to a DNS server, even one that's close to you, depending on where you live and what servers are close to you, that can be anywhere from 10, 20, all the way up to 400, 500 milliseconds or so. So we're talking, two or more orders of magnitude difference in the round trip time between these two paths. So getting a query returned by your pfSense box on your local network is significantly better than going out to the internet every single time you want to resolve an address. And this will help with not just web pages, but also other programs that resolve addresses themselves. And if you don't believe me, if you still aren't totally convinced that Unbound really does have a profound impact on performance, this is my real pfSense router. This is running 2.2.6, and it's running DNS mask actually. But this is a real-world test that I generated, and you can see my router, which I've highlighted in green here. It's at the top. It is the fastest. In this case, the shorter bars are faster. They're a shorter round trip time. So you can see I have a bunch of DNS servers. Most of these are all publicly available. They're publicly known, and you can see that the mean response duration, this is basically the average, is less than half of the next best DNS server, and the fastest response duration, which would correspond to the cached results. You can see how incredibly short that is compared to even the next best server. So you really do get a performance improvement with running a DNS cache. And the more devices you have on the network, the more DNS traffic you normally have, the more of a performance improvement you'll see, because the more traffic will end up being cached. So next, I want to move on to actually showing you how you can generate these exact graphs in a big report on your PC right now, given your current situation. And it'll allow you to find which DNS servers that are closest to you are the fastest in your given area and given your current connection. And you can then use those and actually plug those into pfSense and so basically not only will pfSense be improving the speed by doing caching, but when pfSense does have to go to the internet and retrieve something, it will be using the fastest servers possible. So it'll give you sort of the best that you possibly can have in your situation. So without further ado, let's move on to benchmarking. So the program that I use for doing DNS server benchmarking is a program called Namebench. Now, Namebench is currently in the process of undergoing a massive rewrite for version 2.0, and this is being done by Google. And right now, Namebench 2.0 is quite difficult to use because you have to set up a build environment for it and everything like that. It's not easy to use really at all. So I generally use the sort of the old legacy version of version 1.3, which is still available on code.google.com. And of course, this will eventually be taken down, but you can still download the source code, the Windows executable, a Mac DMG, as well as, of course, the source code is pretty much for Linux primarily. If you're running Linux, you generally don't need this. Namebench is sort of an archaic piece of software, and it's available in pretty much all standard repositories. So you can just, if you're on Ubuntu, for example, you can just do apt-get install Namebench, and you'll get the 1.3 release. So it's very easy. And in Windows, it's also very easy. I have not tried the Mac version because I don't own a Mac. So I can't verify if that still works correctly, because I mean, these are 6-year-old binaries, but I would assume that it works fine. So I'm going to do this on Windows simply because this is the VM that I've got, and that's what I'm screen capping from. But anyway, so I've just downloaded the Windows version, and it's just an extract and run. There's no installation required. And what you're going to get is a sort of an ancient-looking GUI. On Linux, I don't even recommend bothering with the GUI. You can just run it in a command line because the GUI doesn't really help at all. It's not really, there's nothing that you can't do in the command line that the GUI can do. And basically, what you want to do, I'll mention this before I start. If you don't have a pfSense box in place yet in production, then there really isn't much setup you have to do for this. If, on the other hand, you are, if you have a pfSense box in place, in production, if you've modified the DNS servers, then you probably want to maybe remove the custom name servers that you've added, because what they'll do is, of course, your pfSense box is going to use those, and it's going to skew this test. So basically what you want is you want the name servers that Namebench uses to be the ones that your internet service provider has provided you. And by leaving this box checked, this include global DNS providers, Namebench knows a bunch of publicly available DNS servers that it will include in its tests. It will use basically those servers as well as the ones that are listed here. And these were auto-populated, because these are the ones that are distributed to my machine via DHCP. So the 1.1 is my my pfSense box that I've got running in a VM, and this other address is actually due to another NIC. I actually have multiple network cards in this machine, and this is my real pfSense box for my real network, because this is a double networked setup. Unfortunately, I do apologize for sort of the confusing nature of this, because I've got I have a network within a network, and it's just how it is, because I have to do this virtually so that I can make it easy to screencast and set up and tear down and things like that. But anyway, I'm going to remove my actual pfSense box. Now, this is going to be a skewed test. I'm going to say that right away. This is going to be a skewed test, because this virtual machine, this pfSense virtual machine, is going to be caching my real pfSense box, which is caching real servers. So I expect some interesting results from this test. I have not run this test yet, so I'm not quite sure what's going to happen. But anyway, give your ISP's DNS server in this box if it's not auto-populated. If you have a wireless router or some off-the-shelf thing, it may run some form of DNS mask or something, and it may actually put its address here. So just have to look into how your network is currently configured for what goes there. I leave these checked, of course, because that's what we want to do. We want to benchmark the ISP's servers based on compared against public servers as well as regional servers. I generally include censorship checks. Whether that's even still valid, I'm not quite sure, but it doesn't hurt to include that, and you can of course upload your results if you wish. I generally recommend to do that as well. Now, one thing that you'll wonder a little bit about is this data source here, and what you see listed here will vary depending on what software you have installed on your system. And what Namebench will do is it will send a large number. Basically, it'll start by checking which servers it can reach in the list of servers it knows about. And then the ones that it can reach, it picks the best ones of those and then sends a large number, in this case 250 queries to each server. And it measures their response time. It compares them against each other to make sure they're not returning invalid responses, things like that. And it does this using real data. So those names that it asks the server to resolve are actually, they can be based off of your actual usage. So in this case, when it says Google Chrome, what that means is it's actually going to use the cache, the history from Google Chrome of what websites I've browsed, and it will actually pick those 613 and use those. Now, this is a VM. I don't use this. So the reason why this number is so low is because I really don't browse. There's really not that many domains for it to choose from. But if I did this on my regular PC, this number would be 65,536. It'd be the maximum number possible. And generally, I always use my actual sites as the test data. But you can also use Alexa rank sites as well if you want to. I'm just going to use this because it's a small number. So anyway, I generally don't bother with all the rest of the stuff, and I'm just going to run this test, and I will basically, it will check the availability. So this is basically just pinging and making sure that the servers that it knows about, the 4,500 servers it knows about, are available. And once it does this, it's going to go through an iterative process where it's going to slowly chop that 4,500 servers down until it has a list of about the 10 best servers. And you can watch it do this in this status at the bottom. If you're running this in the command line, like on Linux, it will actually dump all this stuff into the command console, and you'll get a bit more information than this. But anyway, I'm just going to pause this and we'll come back once it has completed the test. So through the magic of YouTube editing, I'm back. One thing that I probably should have mentioned before, in case you were for some reason doing this in real time, is that this will take quite a long time. This test is somewhere between half an hour to an hour to run. And during that time, you probably don't want to be pushing your internet connection to its limits. You can use it, of course, but don't saturate the bandwidth, because when you do that, you will inevitably cause packet drops, and that will skew this test. And this is a test that you really want the right answers for, because, of course, if you get, if Namebench gets an incorrect result, it could impact the performance of your network. Until you do the test again. And I generally repeat this test once a year or so just to see if anything's changed. It usually doesn't, but might as well. It's not hard to run. So anyway, once Namebench is done, it will actually give you, it'll open up a browser or open up a tab in an existing browser, giving you a nice report. And right now, I haven't looked through this report, but it's telling me that there is another DNS server which is faster than the one that the ISP has given me. So that's an interesting. That's very interesting. So what Namebench has done is it's shown me a better server. So what it recommends I do is it recommends I use this Primus server as my primary server. The secondary server is the one I'm currently using right now. That's the ISP's server. And it thinks that the tertiary server should be something from my ISP. So in this case, these are the addresses that you want to put in pfSense's DNS configuration. Of course, you don't want to put in it itself. It already knows about itself. So these would be the other two addresses that we'd want to use. And we can add more as we go down. So it gives you a list of all the servers that it tested, and it gives you all sorts of statistics. It gives you notes and all sorts of other things. And then we have the graphs, of course, that I showed you previously. So you can see here there are DNS servers that are actually faster on average than the ISP's DNS server. So actually these are the ones that we're going to want to put into pfSense so that it caches those. Of course, pfSense is still faster on the the individual response, of course, because it can cache certain things, but it's not the fastest overall. There's nice distribution charts and all sorts of fun stuff, and you can download this as a CSV. It's basically it's a self-contained HTML file, but you can download a CSV if you want all of this data. So yeah, that is the output from Namebench. So what we're going to do is I'm going to move to my pfSense web interface, and I'm going to move to System General Setup. And this is where you're going to find a list of DNS servers. So what I'm going to do is I'm going to take the addresses and we're going to put them here. So I'm going to leave this, I'm going to leave the DNS server override enabled, and this is the basically when this is checked, pfSense will use the DNS provided by the modem, which I still want it to do. I'm going to include those two, and I'm also going to include some other DNS servers as well. So I'll pick, in this case, I will pick OpenDNS as my third server. You don't have to include 4 servers. Generally speaking, I would include, generally the way that I do it, this is just my personal preference. I include the 3 fastest servers that Namebench provides, and then I provide Google's OpenDNS, and I hard code that in there just because OpenDNS sort of always exists, and it's not a bad thing to cache. It's generally very correct, and that's kind of what I like about it. So anyway, this is the way I do configuration. Generally, all you want is 2 or 3 fast DNS servers in this list, usually in addition to your ISP's DNS server. And I will just save this. And that is the core DNS config in pfSense. So now I want to move on to actually doing the DNS resolver, the unbound configuration. So under DNS resolver, we of course have the general settings. Of course, we can enable or disable the resolver, so of course we want to leave that enabled. The listen port, this is basically the TCP port which Unbound binds to and listens for clients requesting DNS lookups. So in pretty much all cases, you're going to want to leave this the default, and you're not going to want to change it, because otherwise things are probably not going to work properly. Now, there are two sets of network interfaces you can select. Network interfaces is basically the list of interfaces that Unbound will listen on and respond to. And generally speaking, you're going to want it to, of course, respond to queries from devices on all interfaces connected to your router, unless there's some weird thing that you want, if you have some subnet that you don't want to have DNS resolution capability on, you can explicitly select everything but that. But that's a kind of an odd thing, and I don't think most people are going to want that. Outgoing network interfaces, this is basically the list of interfaces that it will send queries out on to try and basically the interfaces it will use to send queries to authoritative servers to get actual lookups done. So of course most things are going to go out your WAN. However, it is possible to have other DNS servers on your network. On your LAN, for example, you may have a dedicated DNS server, or like in a business environment, for example, or you may have some service that's running its own implementation of DNS for some program or daemon or something. So generally, I leave both of these on all, and then things don't break. The local zone type, this is kind of complicated as to what this actually sort of is. And I generally don't recommend changing this if you don't understand what this does. If you really want to know, you can read the manual online as to what this actually does. But it simply has to do with how queries are handled on your local network. So pfSense, of course, has its own domain. In this case, this example machine is .local domain. Basically, if I want to resolve an address at something.local domain, then this, in the event that that host name exists, of course, Unbound is going to return the result. But if I try to look up, some random host name.local domain that doesn't exist, then this setting basically tells Unbound how it should handle that situation. And generally, transparent is a pretty good default. Dns Sec is Dns Security Extensions. So this is basically a standard which is put on top of DNS to help secure the communication between your device and a DNS server. Of course, you don't want a man-in-the-middle attack, someone swapping out DNS results, the IP address with some malicious IP address, and masqueraded as a valid resolution. So generally speaking, you want to leave this enabled, and it will use the security extensions whenever possible. So the next setting is Dns Query Forwarding. When this is disabled, queries will basically be directed to root name servers, and when it is checked, those queries will go to upstream DNS servers that the ones that you've defined in the general setup, the ones that we just entered. And it's really something that you should only enable if you can trust the upstream DNS servers, and they also have to provide DNS security extensions to really be properly trusted. So generally speaking, I always leave this disabled and just go straight for the root name servers. So the next option is Dhcp Registration. When this is checked, clients that have basically valid leases with the Dhcp server, their host names will be added as a host override to the DNS resolver. So if I were to connect a laptop named Faraday, for example, to my network, of course the DHCP server would get that host name from the machine and it would register it in Unbound. So that way, if I was on another computer and I tried to resolve Faraday.local domain, it would return the IP address of the current lease for that machine without me having to manually enter that in as a host override. So checking this can actually be quite useful on some networks. I generally like to lock down my networks, and I don't like to have machines just creating host names. But most people probably will enable this, but I generally just don't. The next option is static DHCP. So this is basically the same thing, except instead of dynamic leases being registered, it registers static mappings with the resolver. So this would be more sort of my thing, but I'm sort of masochistic and I like to manually enter everything. So yes, I kind of have to enter everything twice, but that's just the way I've always done it. And that way I have much more fine control over host overrides and things like that. But I think most people will probably want to check both of these because they're just very useful features. The next button here, this is for custom options, and this is where you can enter in actual configuration file type parameters for Unbound. So of course you'd need to read the Unbound manual to understand what you could put here, and if you want to do something quite advanced, you can do it here. But I'm not going to be going into anything that advanced. I don't think that most people who are watching these videos will be entering anything like that. The next section is host overrides, and what a host override basically is just a manual entry into, basically it's providing a manual host IP mapping for your Unbound server. So you can add a mapping, and what you do is you enter in the host name. So let's say that I have this magical laptop named Faraday, for example, and the domain is going to be on my network. This is a local domain, and I want to give it an IP address of 192.168.1.150, for example. And you can give it a description. This is not actually used by the server. It's just purely for an administrator note, basically. And I can then save this, and I can then apply the changes all at once, basically. So if I had to add a bunch of these, of course, when you apply the changes, it will restart Unbound. So rather than it restarting after adding every host, you can add a bunch and then just apply all the changes at once, but I'm only going to add one, so I'll just apply the changes now. And so now, whenever I try to resolve Faraday.local domain, it will return this IP address. And I can, of course, edit that or remove that. One thing that you can do is you can add additional names, so additional host names that will resolve to that exact same IP address. And this is really useful if you're running something like a web server, like Apache or something that's got virtual hosts that has multiple domain names that do different things when you connect via different names. So it can be very useful for managing stuff like that. Also, if the machine happens to be available on multiple domains, it spans multiple domains or does weird things like that, you can also enter in all that stuff here. And going back is kind of annoying. There we go. Okay, so the next part is domain overrides. And this is basically how you can override a a domain that would normally be resolved outside of Unbound. So if you had a domain name on the internet that you wanted to forcibly modify and return your own result for it instead, you can enter that in here. But most people probably won't want to do that, but there are some situations where this is useful. Moving on to the Advanced Settings tab, the first two options here for hide identity and hide version, these are enabled by default, and I highly recommend you leave these enabled. What these do is they basically prevent Unbound from responding to queries that ask for the server information or Unbound's version information. And this is purely for sort of pseudo security. Of course, an attacker is going to query your DNS server to see what version of software it runs. And if it happens to run a certain version that's maybe not up to date or whatever, they can look at a known list of vulnerabilities against it and then try and attack you based on those vulnerabilities. So if you block those version and identity query types, then you basically, the attacker won't have a way of knowing what software version you're running, and it makes their job a lot harder. It doesn't actually fix the exploits or prevent them from exploiting your system. It just makes their job harder because they don't know right off the bat what exploits are possible. So generally speaking, I don't see very much of a reason to ever disable those. The next option is Prefetch Support. So when this is enabled, when this is disabled, first of all, when a query is made, the result is returned from an internet DNS server and it's cached. And it's cached for the TTL, the time to live, at which point it expires, and the next time that DNS, that name is looked up, it has to go out to the internet again and come back. With Prefetch Support enabled, basically when just before that record is about to expire in the cache, Unbound will automatically do an unsolicited request to an external DNS server to refresh that cache entry such that it will never expire in the cache. Popular entries will never expire, and this can improve the performance on that one query just after it expired that would normally have to wait until the internet DNS server can return the result. Now this, of course, increases the traffic, the DNS traffic on your internet connection and on the router because, of course, it's fetching things that it may not need to fetch. But you probably have an overpowered router, so the increase in load on the router is completely negligible. And DNS traffic is not terribly heavy, so it's probably not a bad thing to enable, and I'll be enabling it for this, but it's totally up to you whether you think it's worth enabling or not. I think it is because it's really not that much overhead. The next option is Prefetch Dns Key Support. So this has to do with DNS Sec, and it's a little bit complicated what this actually does, and of course there's even a link to Wikipedia right here if you want to read about it. But I actually want to enable this because it reduces the time taken to do some validation processes with DNS Sec, and it uses a little bit more CPU power, but again, you have an overpowered router, a little bit of extra CPU is completely negligible. It has no performance impact pretty much whatsoever. So enabling this just makes things a little bit faster, so I don't see any reason as to why you shouldn't do that. The next option is to harden DNS Sec Data, and basically I would leave this enabled at all times. Basically, if you have a trust anchored zone that does not have DNS Sec Data returned for it, then Unbound will simply discard that zone and it becomes bogus. of course, if it's supposed to be trusted and it doesn't have any security data, it can't really be trusted. If you disable this, then it will mark the zone as insecure, but unless you have a problem with a zone, I would generally leave this enabled for security purposes. The next option is the message cache size. So this is how much memory is allocated to the actual DNS cache itself. Now, of course, these sizes are all quite small in proportion to the amount of RAM that you probably have in your pfSense box. Now, 4 megabytes is still quite a bit, but just for the sake of argument, I'm just going to bump mine up because it doesn't hurt. I mean, 50 megabytes out of 6 gigabytes is completely negligible. It's basically nothing. I mean, that's pretty much the entire amount of RAM on my wireless access points, but I mean, that's nothing for my pfSense box. So I'll bump that just for nothing other than the lulz, basically. Then we have outgoing and incoming TCP buffers. So this is the number of buffers each unbound thread will have for TCP queries. Generally speaking, you probably won't ever have to change this, but if you have problems and you do some investigating and you find out that you're running out of buffers, you can always bump the number up. But I don't think most people will ever need to really touch those unless you're in a big environment with a router that's getting hammered all the time with TCP queries. The next option is the eDNS buffer size, and this is basically the number of bytes in UDP datagrams, and the recommended size is 4K, which is the default, and I would recommend not changing this unless you have a problem. And I think if you have a problem, you'll probably know why. So again, most people can ignore that. The next option is number of queries per thread. So this is the number of simultaneous DNS queries that each unbound thread can receive at once. And once this number is exceeded, basically those queries get dropped. They just get deleted and they're not serviced. And there's a slight asterisk next to that, and that has to do with this next option, which is Jostle Timeout. And jostling is kind of a way that Unbound tries to deal with DOSs or DDoSs. And the way that it works is you want to set the Jostle Timeout to roughly 1 round trip time, or as close to 1 round trip time as you can, to your nearest DNS server on the internet. And basically, once the number of queries per thread is met or exceeded, then Unbound will resolve 50% of these queries, and the other 50%, it will wait the Jostle timeout to see if they've been resolved or not. And that 50%, if those queries do not get resolved within 200 milliseconds in this case, or you can change the value. If they don't get resolved in that period of time, then they're just dropped, and then they're replaced with newer incoming queries. And the idea behind this is that if someone is trying to DDoS you, they're sending in a bunch of very difficult to process queries, because DNS is a recursive structure to resolve addresses. So there are certain domain names you can give that are difficult and processor intensive to resolve and that are slow for a DNS server to return. So the idea is if you're going to DDoS someone, you're going to send a whole bunch of queries and you're going to send the slowest queries possible. So the Jostle timeout just tries to prevent your system from completely shitting the bed when that happens. But I think most people are going to be doing this on their home network and stuff where you're not going to get DDoS from the inside. So this is probably something you don't need to worry about. But in case you're curious, that's what that is. The next option is the maximum TTL. And of course, like I mentioned earlier, when you get a response from an external DNS server, it's going to have a TTL. It's going to have an expiry in seconds. And basically the owner of that domain has put that TTL on that record for a reason. And it's Probably because they maybe expect it to change every so often or whatever. You can force Unbound to expire it sooner than that TTL and to fetch it more often if you want to keep it more up to date. And the default is 1 day, which is pretty long, so you could reduce this number, but I generally would never do that. I don't think there's any real reason to do that. The minimum value, if you increase this, basically 0 means it will use the value guaranteed, the TTL value that the domain owner has set on that record. But if you increase this value above 0, then what you could potentially do is have Unbound keep a message in the cache for longer than the domain owner wants. And this could lead to problems because it could be a dynamic DNS, for example, where every 15 minutes or something that domain name gets updated. And if you've set this TTL to 1 hour, then you could potentially have issues where it's resolving to the wrong address. So reducing the maximum TTL will add more load, but it won't really cause problems. Increasing the minimum TTL can cause problems, and generally, it reduces the number of queries that you have to send out, but it'll just cause more problems. So I would not recommend changing that value above 0. The next option is TTL for host cache entries. So this is sort of infrastructure data and how long they should be kept in the cache for. The default is the longest, which is 15 minutes, and I recommend leaving that as long as possible. Then there's a number of hosts to cache infrastructure data on. So the default is 10,000, which is pretty decent number of hosts. But again, because I like to increase things for arbitrary reasons, I will just double that because why not? It's unlikely that you're going to even reach 10,000 hosts, but again, if you have a busy network, maybe that'll happen. So might as well increase it. We have the memory for it. It's not a big deal. The next option is unwanted reply threshold. So basically, this is another sort of defensive self-protection mechanism that Unbound has built in. So basically, when Unbound receives an unwanted reply, it increments a counter on each thread, and once that counter exceeds some value that you've set here, it will take sort of what's called a defensive action, and it will basically just clear the cache, attempting to flush out any bad entries that could have potentially gotten in there somehow, and stop all of these unwanted replies from occurring. This is not something that I think most people will need to deal with. Again, just like Jostle Timeout, I'm not gonna bother to set this to anything because I don't suspect that this will ever come into play in a home network like mine. The next thing is log level. So 0 means no logging, 5 means oh so much logging. So 1 is the default, which is just simple messages, but if you want more verbosity, you can increase the log level. If you're running this off of a flash drive, like a USB flash drive or something, not an SSD, but something that really doesn't have a large number of writes, and you're not using a RAM disk, even if you are using a RAM disk, generally only increase the log level if you need to. You can always bump this up temporarily to investigate a problem and then bump it back down, but increasing the log level on media that doesn't have a lot of write cycles is generally a sort of a recipe for early media failure. The next option is to disable auto-added access control. Basically, with this unchecked, so auto-added access control is enabled, basically all the subnets that the pfSense box is connected to can send in queries and it will accept them. If you disable this, you will manually have to put in IP address blocks that are allowed to talk to Unbound. So generally speaking, I would always leave this, leave it enabled, because otherwise it just gets kind of annoying because you have to enter everything in manually, and I don't really see a reason to do that, because you can always deny access, and that's something I'll show you in the next tab. The next option, the last option here, is experimental hex 20-bit support. You can read this little draft that they've linked in here to IETF. It describes a little bit about what this does. It's designed to prevent sort of man-in-the-middle attacks by adding a little bit of extra data to the DNS queries. I'm not going to enable this because it is still experimental, and I can't be sure that it will always work correctly. But if you want to play around with that or read about it and maybe enable it, go right ahead. There's probably not a big deal to do it, but I'm just not going to bother. And the last tab is the access lists. And basically, when you add an access list, you can give it a name, and you can give it an action and a network block. So basically, all you're doing is you're saying that addresses that fall within a certain address block are either denied, allowed, or refused to access the DNS server. So normally with that option on the bottom of the advanced settings page disabled, then all of the subnets that are connected to the pfSense box are automatically added, and they can automatically access the DNS server. But if you wanted to deny explicitly something, you could do that. I'm not entirely sure why most people would want to use this on a residential network, but in a business network, this could be useful for security, or for potentially if you have, like, say, a special DNS server on one subnet that runs just that subnet, but nothing else, then maybe you would want to force all the clients and ensure that they use that server, not this server. So maybe you'd want to deny clients on that subnet, something like that. But I don't think most people are going to be dealing with these. So that really covers pretty much everything to do with the DNS resolver. It's really quite simple to set up. It's quite fast. Once you've done all of the benchmarking and you've added in the DNS servers in general setup, and you've just gone through this and set it how you like, it should be working perfectly fine. And it has a log under System Logs DNS Resolver, and you can see this is, of course, with log level 1, so it's not really going to be logging very much. But of course, you can increase the verbosity and get more logging. But yeah, that's pretty much it for DNS. DNS should be working correctly. One way that you can verify that the DNS resolver is working correctly is to use the network for a day or two and then run namebench again, putting in your pfSense box as the name server, which should be appearing automatically like it did in this case, and do the test again. And like on this, we got an external DNS server was faster. You should get where your current server is faster, and it doesn't recommend you change anything. That would mean that you've done it correct. And you should see faster than you did before. So you can see where this is located. So I would recommend backing this file up, copying it out of this temp directory, and putting it somewhere. And that way you can sort of keep a historical record of before you tweaked Unbound and then after you tweaked it. And that will give you sort of an idea as to what the performance difference was. But of course, you've got to use the system in between the time you set this up and the time you do the second test, because of course it's a cache, it has to populate. So anyway, so hopefully that was comprehensive enough, and you got something out of that. So next video will most likely be on firewall rules. So I'm going to be going over firewall rules, setting up other subnets, as well as how to do NAT forwarding, things like that. And from then on, I'm not entirely sure. I've got a couple different directions I can take. I will most likely be going over Traffic Shaper and things like that, but I'm not promising, but definitely part 8 will be on the firewall. So anyway, until the next video, hopefully that was helpful and interesting. Thanks for watching.